Okay, let's give you guys some practice. So given this series, find the original function for which this series represents. So press pause and have a go. Okay, so to do this, try and spot this pattern here. Here you've got a 2, 3, 4, 5, 6, 7, and so on. You've really got n factorial at the bottom, and then this is after the constant. This is your next term. So it would be x to the power 3. But then to get this 6, you would square it. To get this 9 here, you would cube it. To get this thing here, you would to the power of 4. So this thing here is really to the power of n. So you're looking for something of this form. So you've got n factorial at the bottom. Well, it won't be this because this is 2n plus 1 factorial. It won't be this. This is 2n factorial. You're looking for n factorial. This one here looks good here. So you've got n factorial at the bottom for e to the power of x, and then you've got a bubble to the power of n. So really, you've got the bubble to the power of n. So once you get to this stage here, you should be able to spot that it's e to the power of a bubble. It would be e to the power of the bubble. So let's start again here. So given a series like this, rewrite it in sigma form. That will then give you this. And then once you get to here, realize that this is of the form something to the power of n over n factorial. Well, that's really e. That's really, this thing here is e to the power of the bubble, where the bubble happens to be x to the power 3. X to the power 3. So this is your original function. Given this function, it will generate this series. Okay. So next one. So given this series, find the original function for which it represents. So press pause and have a go. Okay, so if you look at this here, so this is squared, cube, and so on. So when you look at something like this, in your mind you should be visualizing this 4x to the this 2, 3, and so on. So you should be visualizing this in your mind. So you're looking for something. So you're looking for something of this form here, and then here you've got negative, plus, negative. So you've got the alternating components of it. So you should be looking out for something which has an alternating component to it. So it would be -1 to the power of n. So you should be looking for something of this form with a negative, with the alternating component. So what you've got here is a bubble, which is 4x, to the power of n, and then it has an alternating component to it, and then you've got your sigma here. Well, this thing, well, you're right. You should be able to spot it. That you should be using this, because here you've got something bubble to the power of n. You can't really see it; it's a bit small. You've got something to the power of n, and then you've got your alternating component. So you should be using this. So let's start again here. Given this series, rewrite it in sigma notation. So that will then give you this, and then from here you should visualize it like this: something to the power of n, and then you've got your alternating components, and then this you should be able to spot that is this, and then that will then give you. Hang on, let me think. No, I made a mistake. You should be able to spot that it's this, because here you've got bubble to the power of n, and then you've got your alternating components. You should be able to spot it's this, in which case you should be using 1 over 1 plus the bubble. So, hang on. Once you get to this form here, you should be using 1 over 1 plus the bubble. Well, the bubble happens to be 4x. So this here is your original function. So given this function, it would generate this series. Okay.